Okay, she voluntold you.
Introduction to logic. I will discuss the truth value of statements, create truth tables, and encounter examples, and use operators and quantifiers to alter my logic statements.
Lovely. We're going to do a lot of stuff today with logic. Before we get into what all of these things are, before we get into a lot of what these things are, I just want to have a brief conversation with you about what truth values are. In logic, in truth tables, there's really only two possible answers. Yeah, true or false. It's like the lights. They're either on or they're off. I don't have a dimmer switch. There's no in between. So in logic, you're only ever going to end up with true or with false. And here's the mind blow moment. All of our electronics, your phones, the computer, the projector, all of it, all runs on it's true or it's false. The electricity is on or it's off. That's it. Everything that we've done with all our technology today is all based on that concept. Take a look at this statement number 2. Birds fly. True or false?
True.
Awesome. Can you think of a bird that doesn't?
Penguin.
Penguins, ostrich, both of you at the same time. Kiwis. Okay, chickens fly. They just don't do it very well.
They just jump,
Yeah, so we'll count falling with style as flying, okay? Kiwis related to ostriches. Turkeys, no, turkeys fly. Yeah, the wild turkeys. Peacocks also fly. Again, they don't do it very beautifully, but they fly. So now that we have stated at least one bird, we've got 2, maybe 3 with the kiwi, that don't fly, is this statement still true?
Yes.
Birds fly.
Yes.
It's still true because it doesn't say all birds fly, it just says birds fly.
Okay, and I like this argument. You're saying no, it's false automatically because if it's a bird, this statement says if it's a bird, it has to fly. And you're going, but we're not quantifying. We're not saying specifically how many birds. The thing is we have to err on the side of, is it a bird? Yes. It flies.
Yes.
And if we get a no, then this statement can't be true. Because sometimes it can be false. And so in logic, anytime you have a single example, a single moment where a statement is false, the whole statement is always false. This statement that you find, this example to show that your statement is false, is called the counterexample. The counterexample is an example that shows the statement is false. Now, you had mentioned something very powerful. You had said it doesn't say how many birds fly. It just says birds fly. So we don't know if that means all birds or some birds. And so what you did was your mind was already thinking about adding some sort of quantifier to your statement. Some sort of word that alters the truth value of whatever statement you're looking at. Quantifiers are all, some, none, many, a few. Any word or phrase that gives a sense of how many or how much gives you a sense of quantity and therefore is a quantifier. Thank you for the applause. she had already changed for us number 1 with a quantifier. Some birds fly. And that's always true. Because it allows for the instance of some birds that don't fly, and we're still okay with that. What we can do, one other thing that we can do to our truth statements, our logic statements here, is do some sort of operation to them. Operators are going to change the actual statement itself and thereby affecting, possibly, the truth value. So an operator changes the statement or combines statements. And when you combine statements, you call it a compound statement. This is very much like your writing class. You have 2 simple sentences, right? The cat sits. And then a statement of the dog runs. And you want to combine them. And you go, the cat sits, but the dog runs. Okay? That would be some sort of compound sentence. We took 2 sentences that stand alone and we mashed them together somehow. We can do the same thing in logic, and we do that with our operators. We have 3 operation symbols that we'll study as the introduction, and if you pursue logic further, there may be more that you can add, but we'll just stick with these 3 to start with. The first one is the tilde. Tilde. How do you say it? Tilde. Okay, I'm saying it right. Done. Oh, thank God. We're going to use this symbol all by itself to mean not when we're talking about logic. It's also called a negation. So if I asked you, look at number 2. Negate the statement for number 2. Birds not fly. I love very strictly, you throw in the word not and we're good. It sounds awkward, right? Which is okay, let's clean it. Birds do not fly. Don't fly.
I totally grammar.
You grammar. I grammar too. We'll grammar together. So, yeah. Okay? Okay. This one's our next operator. This is the operator and. It's called a conjunction. Conjunction, junction, what's your function? Oh, you know this song. This conjunction combines statements. So please combine statements 2 and 3 with a conjunction.
Birds fly and deer have a
Perfect. You just put the word "and" between the 2 statements and you're done. You don't even have to worry about grammar. Here's the last operator that we have. It looks like a V, but it's not a V. This symbol is a disjunction, and we say the word "or." When you're ready, will you please combine statements 2 and 3 with a disjunction?
birds fly or deer have antlers.
Birds fly or deers have antlers. It doesn't matter that the sentence doesn't make any sense. Like, what are we talking about? We don't care. We just want the word "or" between these 2 statements and we're happy. All right? Feeling all right with this? Good. So good.
Birds fly or deer have antlers. Just to confuse someone.
Right? All right, let's look at our study guides. The exercises on the front, bottom of the page. Numbers 1 through 4. I'm going to look at number 2 and number 4 specifically. The directions say, use the statements to write a compound for each conjunction or disjunction. Okay, so we're not going to worry about finding its truth value. We're just going to say whether or just write out the statement. So let's look at this number 2 first. P. Instead of the letter P, we're going to replace P. We're going to substitute for P its statement. What is the statement for P?
10 plus 8 equals 18.
Beautiful. So we'll write 10 plus 8 equals 18. This symbol right here, conjunction or disjunction?
Disjunction.
Disjunction. What word do I use for disjunction?
Or.
Beautiful. I'm going to write the word or. And then what is the statement for R?
A rectangle has 4 sides.
Lovely. Put a period at the end of your compound statement and call it a day. Let's do number 4. What is the statement for Q?
September has 30 days.
Or a what? Rectangle?
A rectangle does not.
What is this symbol here? Conjunction or disjunction?
Conjunction.
Oh, I don't know.
Conjunction.
Yeah.
So which word is conjunction?
And.
And. So we have to write the word and. What's the next symbol?
Not.
Not.
Rectangle does not.
So we're operating on R. We have to make the statement for R the opposite. Put in the word not somewhere. Our statement is a rectangle has 4 sides. So what's
A
its
rectangle
negation?
does not have 4 sides.
A rectangle does not have 4 sides. Feels all right? Okay. That's like the first half of your skill practice right there. Is just that. Easy peasy, lemon squeezy.
You know how bad it was? My nose got uncongested because that's how hard it was.
Holla. Let's talk about truth tables real quick. And this is the last thing. We're sitting on about 20 minutes to the end of class. I want to finish this and give you 10 minutes at the end. You're very welcome. All right, truth tables. We saw when we were writing these conjunctions and these disjunctions that we had these P's and Q's, these letters to represent different statements. Okay? And we know how to combine these things, but how do we get these to change truth values? Well, let's look at this statement real quick. Okay. First off, let's fill off our truth table. So we're going to put combinations of true and false under each statement letter P or Q. And we're going to do that so we have every combination of these two things being true or false together. Okay? So you have a row where both of them are true, a row where the first one's true but the second one's not, then the other way, and then both being false. Okay. Let's let the statement P be the statement Jack went up the hill. And we're going to have Q be Jill went up the hill. If we use the and operator and made the statement Jack went up the hill and Jill went up the hill, what has to be true for that entire statement to be true? In order for Jack to go up the hill and Jill have to go, and try that again. In order for the sentence Jack went up the hill and Jill went up the hill to be a true statement, how many of them have to go up the hill?
1, 2, 3.
Both of them. Because we want both of them, Jack and Jill. We don't want Jack or Jill. We don't want none of them. We want both, Jack and Jill. So on our truth table, P and Q, where P is the first statement and Q is the second, we need 2 truths in order for P and Q to be true. How many truths do we have?
2.
So it is,
True.
how many truths do we have?
1.
So it is,
False.
next one,
False. It's true.
and the last one?
True.
It's false. How many truths do we need?
2.
How many do we have?
9.
So it is. Let's look at this for the or. Thinking about this in the same statements. This time we have Jack went up the hill or Jill went up the hill. In order for that to be true, how many of them have to go up the hill?
One.
Just one of them. Both of them could, and it would be okay?
So it has to be true more. Really?
What do you think? If both of them go up the hill, is it still true?
Yeah.
Yes. And this is where things can get tricky because you can have something called the exclusive or, where it's only one or the other. We can't have both. That's not what this one is. Okay? This one is just a kind of a loose or. It can be one or the other or both of them and no one cares. Okay? So how many truths do you need for an or to be true? One. Okay. How many truths do you have?
Two.
So is it?
Well,
True.
It's true because we have one. How many do we have? How many do we need?
One.
So it is. How many do we have?
All.
How many do we need? So it is. How many do we have? How many do we need? So it is. Let's try to make it more complicated. That symbol says not P. Basically, take the truth value of P and make it the opposite. The truth value for P is, what do I have already for the truth value for P? True. So the not P is, I have true, it is, I have false, I have false. Let's try to make it more complicated. There is a very fundamental difference between the two statements I just wrote. The first one is read, not P or Q. The second one is read, not P or Q. Do you hear just in saying it, you get this sense of things being grouped together? The first one, the not operator is affecting just the P, and then you're checking or Q. And on the second one, the P or Q is lumped together. So you have to check that first and then take the negation. Okay? So let's run through the truth tables for both. We want not P or Q. So I'm going to look at not P and I'm going to look at Q. How many truths do we have?
one.
How many do we need? This is an or statement. We need one. I have one, we need one. True or false? How many do I have? How many do I need? So it is false. Because I have none and I need one. Looking at the next one. How many do I have? How many do I need? So it is. Last one. How many do I have? How many do I need? So it is. Very nice. The final statement, the one that is, the or is grouped before the negation. Again, which reads not P or Q. If you already have a P or Q column, go to that and take the negation. This is true, so not P or Q is. P or Q is true, so not P or Q is. The next one is true. And the last one is false. If you're doing this and you're not already given the thing in the parentheses, make it. And then take the negation.